Hey everybody, this is Longo and we're back with another edition of Inverse Trig using right triangles, and this time we're just going to draw a picture and use the Pythagorean theorem. Do not forget about the Pythagorean theorem. Is a squared plus b squared is equal to c squared. Also, it might help you in this one if you go back and remember SOHCAHTOA, because that might help you a little bit with drawing your pictures. So, first example says, what is the cosine of basically inverse sine of 5 over 13? Notice there's no radicals. This is drawing a right triangle using the Pythagorean theorem to find our answers. So the first example is going to look a little bit like this. So sine is positive. Sine is always positive. And again, here's a little shortcut for you. Sine is positive in quadrant 1. So we're going to draw a triangle in quadrant 1. Sine is opposite over hypotenuse. So remember, our reference angle is always theta. So opposite is 5, hypotenuse is 13. And now we just need to find what the adjacent side is by using the Pythagorean theorem. 5 squared plus x squared is equal to 13 squared. Subtract to get x squared by itself, so 13 squared minus 25 squared is 144, which means x is equal to 12. So this guy down here is 12. So now really what this question is simply asking us to do is say the cosine of theta is equal to, that would be adjacent over the hypotenuse, which would be 12 over 13. Done. Simple. As long as you remember how to do the Pythagorean theorem and SOHCAHTOA, these questions are not bad at all. It's just that they're multi-stepped. Tangent is negative in quadrant 4, which means we're going to draw it down there. Our theta is always here. Tangent is opposite over adjacent, so this is where we have our negative 3 over 4. Just think in terms of y and x if you're confused on where the negative goes. Down is a negative. And now we're just going to do the Pythagorean theorem again. So we have a negative 3 squared plus 4 squared equals x squared. So that's going to give us 25 is equal to x squared. So our hypotenuse is 5. So when we're working over here, we have the sine of theta is opposite over the hypotenuse, which is negative 3 over 5. And remember, sine is negative down there, so it makes sense that we have a negative answer. Okay, and one more example. You should be able to handle these on your own now. This one just has a weird value to work with, but it shouldn't be too bad. So try it if you'd like. Otherwise, cosine is negative in quadrant 2. That means adjacent over hypotenuse. We have a negative root 7, and our hypotenuse is 5. Pythagorean theorem, we have negative root 7 squared plus x squared is equal to your hypotenuse squared. Remember, squaring a negative turns into a positive, and squaring a square root makes it go away, so we just have 7 plus x squared is equal to 25. X squared is equal to 18, and that means x is equal to 3 root 2. So we know that our y value is 3 root 2. So now this is saying cosecant. So cosecant is the reciprocal of sine. So the cosecant of theta is equal to the reciprocal of the sine. So sine is opposite over hypotenuse. So cosecant is hypotenuse over the opposite. And that's it. Nice easy video this time. Inverse trig with right triangles. This is Longo and I'm out. See you, bye.